see the concept of beta function, and based on the definition of beta function as well as the properties of beta and gamma function, we are gonna solve the numerical. So here I have a numerical for you. So we have to prove that integration from 0 to pi x sin raised to 5x cos raised to 4x dx is equal to 8 pi upon 315. Now the question is how to prove this. So guys, let's see the definition of beta function. So here on the screen you have the definition of beta and gamma function. So first one is the definition of gamma, and other three are the definition of beta function. Now if you'll compare our question, then our question has the trigonometric terms. So it is matching with the this fourth one, that is the definition of beta function. So if I want to solve that numerical with the definition of beta function, then I should bring 0 to pi by 2 as a limit and sine raised to p theta cos raised to q theta as a function. Now in our case we have a limit from 0 to pi, so we cannot apply that definition of beta function. So first of all we need to bring it from 0 to pi by 2. The other thing is, here with sine and cos we have one algebraic term, that is x, but as per the definition we also don't want this x, so I have to do some method, some way by which we should remove this x. Now there are two ways to do this. One is either use the integration by substitution or apply the properties of definite integral. Now if I want to use the integration by substitution, then let me tell you that here already we have angle as x, so we cannot use the integration by substitution over here, because if let's say we would have 2x or 3x or 4x with sine and cos, we would have done that substitution for 3x or 4x as t, but since it is x we cannot do the substitution. So what is the other way? Other way is apply the properties of definite integration. Now we have to apply properties in such a way that this x will be removed from this integration, and then only we can apply the definition of beta function. So guys, let's start. So see here how I'm applying, how I'm selecting the different properties of definite integral to solve this numerical. So first of all here I'll say let the integral is equal to I from 0 to pi x sin raised to 5x cos raised to 4x dx. Now to remove this x from this integration, I will use the property of definite integral like this. So you all know this property, that's it, that is integration from 0 to a f of x dx is equal to integration from 0 to a f of a minus x dx. So guys, by using this property I can eliminate this x. Now see how I am eliminating. So I is equal to, now here the value of a is pi, so I'll rewrite this function f of x as f of a minus x, that is pi minus x. So this will be integration 0 to pi, here pi minus x, this will be sine raised to 5 pi minus x, next cos raised to 4 pi minus x dx. Now guys, let's find out the value of sine pi minus x and cos pi minus x. So it is 0 to pi minus x as it is. Now sine pi minus x is sine x, and raised to 5 will become sine raised to 5. Now cos of pi minus x is minus cos x, but raised to 4 will make it positive cos raised to 4x dx. Now guys, we'll multiply this bracket with sine raised to 5x into cos raised to 4x. So we'll get I equal to integration 0 to pi. So Now let's see how to solve this. So guys, if you'll see the second integral, then it is matching with the question. So see here, we have started from here and the same integral we got here, and we have considered this as I. So I can say that the second integral is I. So here this will become I is equal to integration 0 to pi sine raised to 5x cos raised to 4x dx minus I. Now we can take this I on the left hand side, that will become 2I equal to, now this pi is outside, and integration from 0 to pi sine raised to 5x cos raised to 4x dx. And now guys, I succeeded to remove that x from the integration. Now if I want to apply the beta function, the definition of beta function, then one more thing is there, that is the limit of integration, and we want that limit as 0 to pi upon 2. Now the question is how to make it from 0 to pi upon 2, and for that we are again gonna use the property of definite integral. So let's see here. So the property is like this: integration from 0 to 2a f of x dx is equal to integration from 0 to a f of x dx plus integration from 0 to a f of 2a minus x dx. So guys, by using this property we can make the limit from 2a to a, so we can make half value of the upper limit. So here the upper limit is pi, so the half of that is pi upon 2, and we can get 0 to pi by 2. So by using this and by shifting this 2 on the right hand side, we will get pi by 2 as a value of I. So I'll say here I equal to pi by 2 inside the bracket. The first integration is from 0 to a. Now here our 0 to pi is 0 to 2a, means the value of pi is 2a, so the value of a will be pi by 2. So this will become 0 to pi by 2, and f of x is this function. So here I'll say integration from 0 to pi upon 2 sine raised to 5x cos raised to 4x dx plus, now let's see the second integration. So again 0 to pi by 2 and f of 2a minus x. So value of 2a is pi, so I have to subtract this x from pi. So this will become integration 0 to pi upon 2 sine raised to 5 pi minus x cos raised to 4 pi minus x dx. Now pi by 2 as it is. Here integration from 0 to pi by 2 sine raised to 5x cos raised to 4x dx as it is, plus here integration from 0 to pi upon 2. Now the value of sine of pi minus x is sine x, and raised to 5 will become sine raised to 5x. Similarly, the value of cos of pi minus x is minus cos x. So minus cos x raised to 4 is positive cos raised to 4x dx. So guys, in short, we are getting the same integral 2 times. So I can say it is 2 times the integral. So that 2 and this 2 will be cancelled. So we will get pi into integration from 0 to pi by 2 sine raised to 5x cos raised to 4x dx. And now to solve this integral, we are gonna use the definition of beta function. So let's come to the definition. So the power of sine is p, and for cos it is q, and integration from 0 to pi by 2. In our case it is 5 and 4. So I'll consider p as 5 and q as 4. So this will be 5 plus 1 upon 2, that is 6 by 2, which is 3, and 4 plus 1 upon 2, that is 5 by 2. So here 3 comma 5 by 2. So I'll say it is equal to pi into 1 by 2 beta 3 comma 5 by 2. And now we'll solve this beta function by using the relationship between beta and gamma to get the answer. So this is pi by 2 as it is, and here gamma 3 gamma 5 upon 2 whole upon gamma 3 plus 5 upon 2. So this is the relationship between beta and gamma. Now let's solve this. So here pi upon 2 as it is, the value of gamma 3, so for that we'll use the property of gamma n, which is n minus 1 factorial. So this gamma 3 will become 2 factorial. Next, for gamma 5 by 2, I will use the property of gamma n, that is n minus 1 gamma n minus 1. So this will become n is pi by 2, so pi by 2 minus 1, that is 3 by 2 gamma 3 by 2, but gamma 3 by 2 is 1 by 2 gamma 1 by 2, and we know the value of gamma 1 by 2, which is root pi. Next, whole divided by, now this will be 3 to the 6 plus 5, that is 11 upon 2, and for 11 upon 2 we'll again apply this property. So 11 upon 2 minus 1, that is 9 by 2 gamma 9 by 2. For gamma 9 by 2 we will again apply the same property. So 7 by 2 gamma 7 by 2. That gamma 7 by 2 will become now we'll cancel the similar terms. So gamma 1 by 2 cancelled, 1 by 2 cancelled, 3 by 2 cancelled. Next, here we can cancel this 2 with 2 factorial because it is 2. So in the numerator we'll just get pi. Next, 2 into 2 into 2 is 8. So 8 will go in the numerator, that will become 8 pi. And if you'll multiply this 9 with 7 and then with 5, then you will get 315. So guys, here we got the value as 8 pi upon 315. So if you'll see the question, here we have proved the given result as 8 pi upon 315 by using the definition of beta function and different properties of beta and gamma function. So guys, I am very sure that you like this video, and if you want to learn more videos on engineering mathematics, and if you want to learn more numericals about engineering mathematics, then do log in to ekida.com today itself, where you will get all the numericals and concept at one place. So enjoy mathematics and all the best.